Faraday's laws of electrolysis. The first law states that the mass of the substance deposited or liberated at any electrode is directly proportional to the quantity of charge passed. Now, in an electrolytic cell, cations move towards the cathode while anions move towards the anode. Now, at the anode, the anions, they lose their electrons, and as they lose their electrons, they are usually liberated in the form of gases. While at the cathode, cations gain electrons, and after gaining electrons, they change into the atomic state. Usually, cations change into the metallic state. So, how much of the gas is liberated at the anode, or how much of the metal is being deposited at the cathode, that is determined according to Faraday by the quantity of charge that is passing through the electrolytic cell. So mathematically speaking, if W is the mass of the substance, then this W is directly proportional to Q, where Q stands for the quantity of charge that is passing through the electrolytic cell. So Q is nothing but the product of current and time. So we are going to replace Q here. So W is directly proportional to the product of I, which is current, and time, or T, which stands for time. Whenever we have a sign of proportionality, we always try to replace it with a constant. So here the constant we are choosing for this particular equation is the letter Z, which is known as the electrochemical equivalent. So next step, what do we have to do? We always have to try and define what does this constant mean. So if we take the unit values of time and current, so if I is equal to 1 ampere, T is equal to 1 second, then the mass of the substance deposited is directly equal to the electrochemical equivalent. So we can define electrochemical equivalent as the mass of the substance deposited by passing 1 coulomb of charge or by passing 1 ampere of current for 1 second through the electrolyte. The amount of charge that is required for the oxidation process at the anode or the reduction process at the cathode, it depends upon the stoichiometry of the electrode reaction. That means how many electrons are involved at any particular electrode. That will tell us how much of charge will be required for any amount of the substance to be deposited or liberated at any electrode. So let us consider a general equation. So if we have a cation which gains electron to become a metal, so we will see now how much will this particular equation require, how much charge will this particular equation require. So let A be the atomic mass of this particular element, of this element M, and N be its valency. So when we say valency, what does it mean? The number of electrons that it needs in order to become a neutral species. So the charge on any one electron, an electron carries a negative charge of 1.602 into 10 to the power minus 19 coulomb. So this is the charge carried by one electron. Now, whenever we talk about the charge, we always want to express it in terms of moles. We don't just express in terms of one electron, we express in terms of mole. So the charge on 1 mole of the electron, this will be the product of the charge on 1 electron and Avogadro's number. So 6.022 into 10 to the power 23 mole inverse is the Avogadro's number. So the product of those two will give us a number which is 96472 coulomb mole inverse. So this particular quantity is what we call as a Faraday of charge. So this quantity is the minimum amount of charge that is required by an electrode in order to carry on the process of oxidation or reduction. So this is the product of the Avogadro's number and the charge of an electron. So usually, for simplicity, this number is usually written as 96500. So we can write 96472 or we can also write as 96500. So this quantity is what we call as a Faraday of charge and it's represented as 1F. So now when 1500 coulomb of charge passes through an electrolytic cell, then the electrochemical equivalent is also known as equivalent mass of the element. So when this much of charge passes through the electrolytic cell, so the product of electrochemical equivalent with this charge gives us a quantity E. And what is E? E is what we call as the equivalent mass of the element. So we can also write Z as being equal to E divided by 1 Faraday. So E is a quantity which is derived when we take the ratio of the atomic mass of the element and we divide it by the valency of the element.